Okay, so let's talk about one more thing before we move on. Pretend like you don't see these. What's the square root of 9? 3. Isn't 3, when we're multiplying, half of 9? This, when you're using exponents, doesn't that mean multiplication? Doesn't 9 equal 5? Doesn't 9 equal 3 times 3? So isn't half of that multiplication problem 3? You see it? It means the same thing. It's just another way of writing it. Okay? Let's take it one step. We're going to go further with it. Let's take it one step further. Okay, wait. Armando wants me to say it again. Isn't multiplication, right? Doesn't 3 times 3 equal 9? So isn't one side of that multiplication problem half of the multiplication? So 9 to the 1/2 is 3. I'm going to say it another way. So if we can rewrite the square root as half of the square, couldn't we write 9 to the 1/2? Because this is really 3, right? And this is really 3, correct? We decided that's true? And isn't 3 times 3 9? Okay, let's look at it with just using the fractions. 9 to the 1/2 times 9 to the 1/2. Isn't 2 1/2 make 2 halves? Isn't that a whole? It'll become clear in a minute. How else? Pretend like you don't see any of this. What's another way to figure out what the side of the square is? No. How would I figure out what the side of the square is? Well, where did you come up with that? Just with this number here. It's the square root of 9. Right? Isn't the side of the square root? Isn't it?
Yeah.
Isn't that how we found it? Which is 3. So this symbol right here, guys, 9 to the 1/2. Whenever you see a half in a fraction, in a exponent, it means square root. No, it's not a trick. It's just another way to write it. It's the same thing. They're not trying to confuse you. There's reasons to use it later on. That being said, can you guys tell me what this would look like?
Yes.
It's a huge root. Good job. Okay, so let's look at some more examples. Example 1, 25 to the 1/2 really means the square root of 25, which is 5. 8 to the 1/3 really means the cubed root of 8, which is 2. What about this one? Doesn't 3, read this with me, how much is that?
6.
It's 3/2, right? So isn't that 1/2 and another half and another half, which makes what does that mean? What does this mean? What does 2 to the 1/2 mean? Square root of 2 times the square root of 2 times the square root of 2, which makes 2 squared times 2, which equals 2 times the square root of 2. Okay, let's push ourselves. Now, I know this looks confusing, but if I were to do this, would you know what that is?
3.
How'd you do that so fast? Because you know stuff. Good. Right? This really means the square root of 9, correct? But then when Patrick's on it now. Now that really means this 3 times, which equals square root of 9 times the square root of 9 times the square root of 9, which equals 3 times 3 times 3, which equals 27. So what's this one, Smarty Pants? Almost. Where'd you get 8 from?
8 times 8.
What's this mean?
Cube.
Cubed root of 64. This is 4 cubed, right? 64 is 4 cubed. We already figured that out. And I need this 2 times. Well, let's kick it out. So it gets kicked out. It's not 8. You're making a common misconception. This is not 8. 16. It means 4 times 4. So I knew what you were doing. You had it, but you just said 4 times 2 instead of 4 times 4. Can't do that fast. How do you know that fast? It's close. Okay, so write this down, guys. Simplifying radical expressions. So now I tell you, we've got variables, and you guys tell me it's no problem. We can see this now. Right? So go ahead and write this down and take a guess at what these two numbers should be. Okay, so what I'm teaching you guys, you will never see this. You will see this. And you'll say to yourself, well, I know that what they're talking about is this. Find squares in here for me. 7 squared, x squared, y squared, y squared. And we have 1 y left over. So when I solve this, what do I kick out? I kick out a 7, and x, and 2 y's, and what's left over? A y. So the side of this box, this square, is 7x y squared radical y. 7x y squared radical y. With your shoulder partner, explain why the only term left under the radical is a y. All right, let's do these together. This should be pretty fast. It's the same thing as yesterday, only we have variables now. What are the squares in here? 9 times 5 times p squared times p. Can I go faster? What gets kicked out? Can you guys see that 3 gets kicked out? What else gets kicked out? The p. What's left over? 5p. I'm sorry, Patrick, did you want to do these? You want a second? Okay. So what are the squares in 200? We went too fast. Not 4 tens. Two times 100, which is 2 times 10 squared. That's it. 2 times 100. You're thinking 1,000.
I got 100.
No. No.
There's no Y in there.
Isn't 200 2 times 100?
No, ma'am.
Isn't 100 10 squared? What else do I have in here?
Oh, yeah.
A W squared, another W squared, and an X. Equals what gets kicked out? The 10 gets kicked out, and 2 W's, and what's left over? 2X. How about this one? Yep. What squares are in here? We're hunting for squares. I see 8. I see 4s. I also see 16 times 2 times r squared. You're skipping a step on me. S squared times S squared times T squared times T squared times T. Am I right? Can we skip a step? What gets kicked out? 16 doesn't get kicked out, but 4 does. Because isn't this 4 squared? What else gets kicked out? R. How many S's get kicked out? 2 S's. How many T's get kicked out? 2 T's. What's left over? 2 T. Yep, that's it. So if I would have showed you this before, you would have said, what?
No, I'm still at 9.5 squared. I mean, 9.5. It's 1. 9.5. It's 1. Boy, 8-1.
If I have 1 over 81, what two numbers, when I multiply, will I get 1 over 81?
1 is 9. Oh.
Right? So this really means 1 squared over 9 squared. What gets kicked out? 1 and 9. That's what this means. Can I move on? So you should be able to do this pretty fast. 5 over 12. Good. Not y over 6. Let's map this one out a little bit. Let's count our squares in y to the 8th so we don't make any errors. Y squared times what? Y squared times what? Y squared times what? Y squared. And what goes in the denominator? 6 squared. What gets kicked out? How many y's? What else gets kicked out? That's it. So far, so good? Can I go? All right, so what do you see happening? What is rad 3 times rad 3? 3 squared, which is?
9.
No.
Where's that?
3. So what's root 7 times root 7? Good.
7.
Y. Z squared. What's happening here? There's a pattern. When I multiply a square root times a square root, it ends up just being
3. Same number.
the same number, exactly. So keep this in mind to help us resolve the next issue. Rationalize the denominator. So what do you think I should do with this? I can't have a radical in the denominator.
You should rationalize.
How am I going to rationalize it with the screen I just had on right here?
No, then you have to divide, so that. Isn't it like 2 over 3 or something square?
I'll give you a hint. The square root of 6. Why can I do that? Because it equals 1. Anything over itself equals 1, right? So when I do this and I multiply straight across, isn't this 4 root 6 over, what's radical 6 times radical 6? Right? Isn't that what we did on this one right here? Rad 3 times rad 3 equals 3 squared, and then you kick the 3 out. Rad 7 times rad 7 equals 7 squared, then you kick the 7 out. You would do that with each one of these. So whenever you have a radical in the denominator like that, to get it away, you just multiply by a radical in the numerator and in the denominator, and you will get rid of the radical on the bottom. This isn't finished, though. Why? 2 times rad 6 over. Now you see in the beginning why I forced you guys kicking and screaming to factor, so that I didn't have to teach you how to factor now. Breaking numbers down is a lot easier. You guys are good at factoring now, right? You see exactly what I'm doing? You're welcome. Okay, so what am I going to do with this one? Multiply it by what? Root 5 over root 5. What's that give me? I don't see squares. Oh, there's a square in there. Let's fish out our squares. This is 4 times 3 times 5. I just combined all of my radicals over, what's root 5 times root 5? 5. What square is in here? 2. Am I going too fast? Okay, do you guys want me to simplify this first and then multiply? Let's do that. Let's break this up. So this is root 7 times 5 over root 2 times 3, which equals, there's no squares in here, so I'm just going to multiply them, okay? So this is 35 over 6. Now what do I do? Multiply by root 6 over root 6. Now what? Do I have any squares in here? 2, a 3, a 7, a 5. I don't see any squares, so we're just going to have to multiply that straight across. What's 35 times 6? What's 5 times 6? What's 3 times 6? Good job. So 210 over 6. I remember when that freeway wasn't a freeway, past baseline. Isn't that crazy? What am I going to do with this? Good job. Multiply it by root 6. What do I get? Let's see, let's combine everything in the numerator. I've got a 2 times n times 2 times 3. And in the denominator, I'm going to write it like this. Why? Because I'm going to cancel later, right? What gets kicked out of here? 2. Root what? 2 2's get kicked out because that's 2 squared. What's left? 3n over 2 times 3. Cancel, cancel. Root 3n over 3. No, you can't cancel. That's inside of a square root. Right? Try this one on your own. Okay, so first I'm going to kick stuff out. All right, so I can't kick anything out in the numerator. So I just have 10xy, but I can kick something out in the denominator. What can I kick out? X. So I'm left with 3y. So what do I have to, how do I rationalize this denominator? Multiply by what?
3y.
Root 3y over root 3y equals, keep going, equals 10 times x times y times 3 times y over x times what? This one's a little harder. 3 times y. What gets kicked out in the numerator? Y gets kicked out. Those are gone. What else? That's it. Over, what's left over? 30x over, hold on, 3x times y, and then these cancel. And I'm left with root 30x over 3x, and we're done.